For Chapter 1, we're going to be dealing with some geometry concepts, a lot of review from what we learned in geometry class. For Section 10.1, we're going to be primarily talking about points, lines, and planes. So just a couple of definitions to review here. A point, represented as a small dot, it has no length, width, or thickness. Okay, so when we consider a point, we consider it to have no length, width, or thickness. Okay, when we have a line connecting 2 points along the shortest path has no thickness and has an infinite length. And when we draw the line, we write it as such. Okay, we also use a symbol for a line, AB, as that, kind of symbol of a line above it. And then finally, a plane is a flat surface, has no thickness, no boundaries. A plane goes on forever in all directions. So we think of maybe the floor as a plane would be a good example. Okay, so a couple of more items regarding lines. Okay, a line may be named using any of its 2 points. Okay, which means, like in the previous example, we had a line that had AB on it. I'm going to put another point on there, okay, called C. So we could name that line. We could name it line AB. Okay, or we could name it line BA. The order when we're dealing with lines does not matter. Okay, we could also call it line BC. Okay, we could call it AC. Okay, or the reverse of either of those as well. So there's lots of different names we could name a line. Okay, provided that we have some different points that are on the line. Okay. The definition of a half line. Okay, a half line is formed when a point divides a line. Okay, and then a ray is a half line with its endpoint included. Okay, so let me give you the difference between those two. Here's a picture of a ray. Okay, so if I had A here and B here, let's say for instance, we'd call this ray AB. Okay, keep in mind we would not call this ray BA because when we do a ray, when we name it, it has to start from the end point going out to another point, and the end point has to be listed first. Okay, so very important that that first letter has to be the end point. Okay. All right. And when we're talking about a half line, we're talking about the distance from A to B, but not including A. That's the difference between a half line and a ray. And then finally, a line segment is a portion of a line joining 2 points. So if I had segment AB, for instance, okay, I could name that AB or BA. And notice the symbol that I put above those two is just a line drawn with no arrows. Ray, 1 arrow going to the right. And keep in mind that no matter what way I draw a ray, okay, even if I had it facing that way, okay, I would still write the symbol as arrow to the right. So for instance, if I had ray CD, okay, I would still name it ray CD, even though it doesn't point the same way as my arrow symbol points. My arrow symbol always points to the right. Okay. All right, let's take a look at a couple more examples. These are going to be pretty much the same thing as what I just did right there. Key example that I want to point out though is right here, the key difference between a half line and a ray. Okay, the half line goes from A through B to the right, if you will, in this case. Okay, but it does not include the end point. Okay, when we write a half line, we write a little open circle symbol on there, whereas a ray, we don't use that open circle symbol, and it's everything from A through B, including A. Okay. And one other point I want to make on this too is this is not, okay, ray BA. Okay, so do not confuse these two. You cannot switch these two because again, this first letter has to be the end point when we're dealing with a ray. With a segment and a line, okay, they can be in either order, okay, but not with a ray. Okay, and also with a half line as well. Okay, next we're going to focus on angles. Angle is formed by a union of 2 rays. If we have 2 rays that meet at an endpoint, okay, we call that endpoint the vertex. The 2 rays are called sides. Okay, the angle in between is called the angle. We can name that in many different ways. In this particular diagram, we can name it by a number. If they put a number out here, we can call it angle 1. If we have a vertex B, we can call it angle B. We can also call it ABC. We can do the 3 letter naming system, and CBA. And the key information right here is that when we do it with a 3 letter naming system, which we do with a lot of angles because sometimes there's more than this many points in the diagram, okay, the vertex has to be in the middle. So vertex always in the middle when we name an angle. Okay, a couple things about measuring using degrees. Angles are measured by the amount of rotation from the initial side to the terminal side. Okay, angles are always measured in degrees for us in this class. We know the degree symbol because we see that often. Okay, we know that there's 360 degrees in a full rotation, which is a circle, and then 1 degree is 1/360th of a complete rotation. Okay. So that said, let's take a look at this problem. It says the hour hand of a clock moves from 12 to 2 o'clock, goes from 12 to 2. The question is, how many degrees does it move through? Well, in this particular case, if you look at the way we have the clock is broken up into 12 equal angles, okay, and if I do 12 divided into 360, okay, each of these angles is going to be worth 30 degrees. So if I go 30, 60, 90, 120, 150, 180, and so on, by the time I get to 12, I'll be back to 360. And so if I do 2 of those, then it's going to be 30 plus 30, or 60. Okay, or another way we can think about it is that going from 12 to 2, I've gone 1/6 of the clock. Okay, and keep in mind the clock would be 360 degrees total. So 1/6 of 360 would get me to 60 degrees as well. Okay. All right. Couple of classifications for angles. One is an acute angle. If I have an acute angle like the one we just looked at, it's going to be something that's less than 60 degrees. If I have an angle that goes from 12 to 3, for instance, okay, and has a 90-degree angle, we call that a right angle. Any angle that is more than 90 but less than 180, we call that an obtuse angle. And then finally, a straight angle is going from, for instance, 12 to 6. Okay, straight. The angle measure here would be 180. Okay, and so those are 4 different angle measurements, classifications: acute, right, obtuse, and straight. Okay. All right. So ultimately, when we have a protractor, we use this to find the degree measure of an angle. A couple of key issues here for the protractor, making sure that we read it correctly, because you'll notice that there are 2 sets of numbers on the protractor that we need to make sure we keep track of. And what it boils down to is we measure the angle by placing the center point, okay, on the vertex. So the center of the protractor is going to go on the vertex. Okay. And the straight side of the protractor along the side of the angle. Okay. It really doesn't matter which side we use. We could turn this whole thing around and use C as our initial side, but since it's horizontal, we'll use this as our initial side. And we read the degree by reading where the other side of the angle intercepts the edge of the protractor. Okay. Now, the question then is, which of these do we read? Because if you look at this, it lies on 50 and 130. So is it 50 or is it 130? And you can memorize a couple of things. Other than that, I would probably just recommend using common sense. Because if you look at this angle from A to B, or from BC to BA, okay, it's an acute angle. So could it possibly be 130 degrees? Of course, the answer is no. Okay, so we're looking at the inside numbers. Okay, so we're looking at inside numbers here in this case. And in that particular case, we'd say it's 50 degrees. Okay. All right, so a couple of more vocabulary words. We use the term complementary to indicate that 2 angles add up to be 90. Okay, so if I have 70, we'd say the complement of 70 is 20. Okay, 70 and 20 are complements because they add to be 90. Similarly, supplements, if I have supplementary angles, they add up to be 180. So if I ask for the supplement of 110, we would go 180 minus 110, and we'd get 70. So these 2 are supplements because they add up to be 180 degrees. Okay, here's a question for us. It says angle measures and complements. We want to find the angle measure of angle DBC. So keep in mind DBC is the one that they have marked with a question mark. We can see that CBA is 90 degrees, and if this part of it is 62 degrees, then there's no choice for that to be anything but the complement. And so if we go 90 minus 62, we get a final answer of 28 degrees. Okay. Next one, similar to the last one. If we have these 2 angles, CBD and ABD, these 2 would be supplements of each other. But this time we're given essentially an algebra problem to deal with. We had some problems like this in geometry. Okay, they told us that ABD, which is this one, is 66 greater than DBC and that they're supplements. Okay, so that means I don't know either one of them. But I do know that ABD, okay, is 66 greater than DBC. So if I called the DBC angle my x my ABD angle would be x plus 66, because again, it's 66 more than the one I don't know. So again, the fact that they're supplements allows us to write the equation that they equal 180 together. And so if we solve that equation, we wind up with 57, so that would be our angle DBC. Okay. And of course, we subtract it from 180, and we could get the angle ABD. Okay. All right, next type of angle we're going to talk about is our vertical angles when two lines intersect. Opposite angles formed are called vertical angles, and vertical angles are always equal. Okay, this was our vertical angles theorem in geometry. Okay, vertical angles are equal, so that means if I know that this one is 68, okay, find the measures of the others. Well, the one that's opposite it would be number 1, and so number 1 would be 68 also. Okay, and then if we look at the diagram, either looking at it this way, okay, or looking at it this way, okay, or this way, either way, the angles that are next to each other in this diagram are supplementary. So if this one's 68, then number 3, of course, is going to be 180 minus 68, which is 112. And 2 is also going to be 112 for two reasons, because it's vertical to the other 112, okay, and it's supplementary to the 68 on both sides. Okay. So bottom line is, if we have intersecting lines and we know one angle, then we really know all four as well. Okay. Okay, one other thing that we did in geometry is worked with an idea with parallel lines. Parallel lines, they have no points in common, of course. So these two are parallel, sometimes denoted by big arrows. Okay. These parallel lines, a line that crosses two parallel lines, we call it transversal. Okay, and this transversal sets up some angle relationships. It sets up 8 angles, and they're all related to each other in one way or another. So let's go ahead and look at this next slide. Okay. These are the relationships. This diagram is right in your book also. Okay, we have, first one here is alternate interior angles. So looking at the diagram, the interior part means they're inside the parallel lines. Alternate means they're on the opposite sides of the transversal. So numbers 3 and 6, okay, and also numbers 4 and 5, okay, those are going to be congruent to each other. They're going to have the same measure. Okay, alternate exterior angles outside the parallel lines, 1 and 8 and 2 and 7, those are also going to have the same measure. And then corresponding angles are going to be as if I were to take the two diagrams and cut it in half here at the middle of the transversal, lift this piece up and put it on top of this piece. The angles that go on top of one another are going to be what we call corresponding. So 1 would go on top of 5, so they're equal. 2 would go on top of 6, they're equal. 3 would go on to 7, 4 would go on to 8. So those sets of angles are always going to be congruent to each other. They will have the same measure. So that next slide we're going to look at here asks us to find some missing angles here. So we're looking at angle 8 being 35. Okay, so if angle 8 is 35, okay, we know that angle 1 is 35 also because they are vertical to each other. Okay, we know that angle 2 is 35 because they're alternate interior to each other. Okay, and if this one's 35 right here, then that one would be 35 as well because these two would be vertical. Okay, not only that, but number 5 and number 8 would be corresponding to each other, so they would be 35 together for the same reason. Okay, and then the other thing we don't know is we don't know any of the other angles that have been mentioned. But if you look at 7 and 8, they make a straight angle together, so that means that 145 would be the only choice for 7. Okay, so only choice for 6. And 7 and 4 are corresponding, so that would also be 145. And another reason it has to be supplementary to these two. Okay, and for that other same reasons, we'd have number 3 would be 145 also. So in this case, as long as we know one angle, when we have two parallel lines and a transversal, as long as we have one angle, okay, then we actually know all 8. Okay, so our work for today is going to be dealing with these geometric concepts. Okay, good luck.